Hi guys, today we're going to look at the quotient rule of differentiation. Now quotient is a word that's not used that often, but what it is the answer to a division. So here I'm going to look at a combined function where I'm dividing two different ones. So previously when we did the product rule we did y equals uv, now we're looking at y equals u divided by v. So let's jump straight in with an example. So find dy by dx if y equals e to the x over cos x. So I'm going to use that side panel again like I did with the product rule and say, okay, well if u equals e to the x, du by dx also equals e to the x, and if v equals cos x, then dv by dx equals minus sine x. So that's set up my initial parts. Then I've just got to put the rule together. So the rule says dy by dx is equal to v du by dx minus u dv by dx all over v squared. So let's take our bits, substitute them in. So we've got cos x e to the x, so that's v du by dx minus u, which is e to the x, times dv by dx, which is minus sine x, over v squared, which is cos squared x. So simplifying that up a little bit, we have e to the x as a common factor in both those things. I've got cos x plus sine x all over cos squared x. And there's our answer. So let's have a look at the second one. Y is equal to e to the x over x squared plus 1 to the 4. So again, go to my side panel and I would say u is equal to e to the x, so du by dx is also equal to e to the x. Well, it's one of my favourite functions. V is equal to x squared plus 1 to the 4, and we're going to need to use the chain rule to differentiate that. So I'm going to say that's 4 x squared plus 1 to the 3 times by the differential of the inner function times 2x. So that would be 8x x squared plus 1 cubed. So let's write out that formula. So important to write that out every time. Make it really stick. So let's substitute our bits in. V is x squared plus 1 to the 4. Du by dx is e to the x minus u, which is e to the x, times the differential at dv by dx times 8x x squared plus 1 to the 3 all over v squared, which which is going to be x squared plus 1 to the 8. Now, one of the reasons I put this in was that I felt that it would really help us think about cancelling stuff out. So we can tidy this up on the top here. I can see I've got a common factor of e to the x and also x squared plus 1 cubed. So we've got e to the x times x squared plus 1 cubed. On this side I'm left with x squared plus 1, and then I'm subtracting 8x, and that is all over x squared plus 1 to the 8. Now you can see that because this is a product of 3 different things and we've got a similar thing at the bottom, there should be some cancelling out to do. If I've got cubed here and 8 there, I think 3 of these should cancel out with 3 of those, so it should leave us with power of 5 on the bottom. So we would be left with e to the x squared minus 8x plus 1 all over x squared plus 1 to the 5. And you need to get your head around that cancelling. So the large part of it is to be able to get to here. That's using the rule. The next part is thinking about the common factors. So the x plus 1 cubed and the e to the x that were there in both, taking out as a common factor, and then looking at what you're left with. So then we can think about cancelling these out. And I would say if you've got a chain rule question going on like this, there's nearly always going to be some cancelling out to be done, and it's something you need to look out for because that's where the real final marks are. So process is side panel, formula, see if you can cancel down at the end. Okay.